Want to look at is electric circuits and the difference between a series circuit and a parallel circuit. So there's two main types of circuits. The first one is a series circuit. It has a single path, one path for the electricity to follow, one path. So when the switch is open, nothing's going to flow through it. And when the switch is closed, the charges are able to move around that single path. So this is like going down the hallway in a single file. There's no place for you to go. You're not allowed to detour from being in that line. This is the reason why a lot of times in holiday lighting, you're in the decorative lighting and holiday lighting, if one bulb goes out, the rest of them will go out. And it's because it's basically opening up the circuit. So if you actually start here at the positive terminal of the battery, and you follow it along, you're not going to have a choice about which path to take. There's only one path for these charges to flow around. So here's the thing. If one bulb goes out, the rest go out. Again, like your holiday lighting, that happens. Now, because there's a single path for these charges to follow, the electric current everywhere in that path is identical. Everywhere in that path is identical. So what about a parallel circuit? What makes it different? Well, with a parallel circuit, there's more than one path. There's a choice. So everybody starts out together, and then you get to choose which path to take. Okay. And most of the time, we would take the path of least resistance. So if you're trying to, if there's a lot of resistance, you might not go that direction in the circuit quite as much because of the high resistance. So here, if one bulb burns out, the rest of them stay the same because the rest of them still have a complete path. So here's an example of a parallel circuit. If I start out at the positive terminal of the battery and I'm moving around, I have a choice. I can go this way or this way. So I have more than one option about which to go. And when I get here, I have a choice. I can either stay straight or veer off. Now, in this particular, in a parallel circuit, when one bulb goes out, these are still going to have current passing through them. It just won't go to this bulb because this line has been closed off because the bulb's broken or it's opened up. So if I remove one bulb, the rest are going to stay identical and stay the same. So in a parallel circuit. Now, this is the reason why a lot of times your houses are actually wired in parallel. Because if one of your circuit breakers pops in, like, let's say the bathroom, because you have too much going on, or in your kitchen, you don't want it to shut off all the electricity to the entire house. So most houses are wired in parallel. So here you can see that this is a parallel circuit. Parallel meaning across from each other. So the battery is across from bulb 1 and bulb 2 and bulb 3 and bulb 4. And you can notice that there's more than one path that could be taken. Whereas here in this circuit, you see there's only one path for the charges to move through. So if you have a choice, like here, you have a choice about which path to take, then you are talking about a parallel circuit. So let's talk a little bit more about these circuits. So here is a series circuit. There's one path in which the charges can flow. So the current in a series circuit is everywhere is identical. So in a series circuit, the current is equal everywhere. However, the voltage potential difference, it adds up. And that's because it's the energy. So as you move around and you encounter the resistance of the first resistor, you use up some of that energy and you have less energy for the next and less energy for the next. And by the time you get back around, you've used all that energy up. And that's basically law of conservation of energy for electric circuits. And so the more resistance you encounter, so the more obstacles you put into a series circuit, the more resistors and objects you place into a series circuit, the less you actually are going to be able to have, right? So The current here is the same everywhere, but the more resistors you have, the more resistance you have, and so it uses up all that energy and the less current is able to flow through. So let's go back over this. So the current is the same, but the voltage adds up in the circuit. So if I added up the voltages, and remember we studied V equals IR or Ohm's law. So if I replace V with IR for each of these, I have IR plus IR plus IR. However, you may remember that the current in these are equal. So if the current here is equal and the current here is equal and the current here is equal, then I can cancel out that current by dividing. And that means that the resistance just adds up. So the more resistors in a series circuit, the more resistance you have. So what about a parallel circuit? So in a parallel circuit, as you move through, the current divides, but you're never going to have more current than what you start with. They all make it to the other side, they just take a different path. So the amount of current we have to begin with has to equal the amount of current passing through each of the paths. And that's law of conservation of charge. The charge that we start with has to be accounted for. They can go down different paths. Now, the energy supplied to them is the same. If I go here, none of that energy has been used before they go through here. So the charges that went down path 3 have the same amount of energy as those that went down path 2, and the same amount of energy that those that went down path 1, because they haven't used any of that energy. And so the voltage in a parallel circuit is equal. This is why if one bulb burns out, the rest stay the same, because they all have the same amount of energy, the same amount of voltage. Okay, so the current adds and the voltage is equal. So if the current adds up and V equals IR, if I solve V equals IR for I get V over R. Now I'm going to replace each of these currents with V over R. Now remember, the voltages are equal. So if the voltages are equal and they're in every single term, what can I do? I can cancel them out. And so in a parallel circuit, we add the resistance inversely, which is the reason why the more obstacles you put in a parallel circuit, the less resistance it has overall, the less resistance it will have. And honestly, this is how I like to wire my stereo, okay? I wire my stereo in parallel because then the more things I put into it, the less overall resistance I'm going to have. And that means the more current that I have when it's attached to my battery. So let's summarize this. In a series circuit, the resistances add together. It has one single path for the current to take, so the current is equal and the potential difference adds together. In a parallel circuit, the current adds, the potential difference is equal, and the resistances add inversely. Hope this helps you understand a little bit about electric circuits and series versus parallel.